Hi friends, good morning. This is Naga S. Remat. I am working as assistant professor in CSE department in MS Engineering College. The main objective of this video is what is NAND gate. I am going to explain what is NAND gate operation, what are the use of NAND gate and why it is called as universal gate. After that, we will simulate NAND gate by using Verilog program with the help of Xilinx software. Come, we'll see what is NAND gate. The symbol of NAND gate for two input. Here I consider A is input variable, B also input variable. The output variable I consider as Y. The definition of NAND gate is if one of the input is low, the output is high. That is, the product of input if goes to low, then the complement of that whatever product will be there, that will be assigned to the output of NAND gate. So the Y equals to the product of inputs A into B, then the complement of the product. So that is A into B whole bar. If you see the truth table for two input variables, 2 to the power of 2, 4 combinations will get 0, 0, 0, 1, 1, 0, 1, 1. If we give the input A is 0, B is 0, the product of 0 into 0 is 0. Then complement of this 0 will be 1. Then another combination 0, 1. 0, 1 product will be 0. The complement of 0 is 1. Then 1 into 0, 0. The product of 0 product is 0 and complement of that will be 1. Then the final combination, that is input A is 1, B is also 1. The product of 1 into 1 is 1. The complement of that will be 0. See here in this truth table you can easily analyze what is the NAND gate operation. Here in the first combination 0 is available, second combination 0 is there, third combination also 0 is there. So your output will be 1, 1, 1. From this we can say easily if one of the input is low, the output is high, otherwise it is low. So you can consider n number of inputs. We can give the only one definition, that is if one of the input is low, the output is high, otherwise it is low. Okay. Now we will see the Verilog program. Verilog program starts with module, then module name I given as NAND gate. Then in the bracket constraints, those are input and output variables. Here input variables I consider A, B and output variable as Y, and close the bracket and end with semicolon. Then we have to separate these constraints which are inputs and which are outputs. So input A, B with semicolon, then outputs is Y. Okay, then what is the main logic? That is Y is equals to, what is the main logic? The Y equals to the product of inputs and over the complement. So assign Y equals to the complement of, in the bracket, product A ampersand B. A ampersand B gives the product of input A into B, then whole complement with the help of this tilde symbol. Okay, so that gives the complement of product of inputs, that is the output for the NAND gate. And finally end module. If you like this, please subscribe my channel and also please like it and share it to your friends. Now we will see the simulation by using Xilinx software. So double click on that Xilinx software. So here you just press OK. Go to file, select file, under file select new project. So here you have to create the project. So give the project name. I'll give the project name as NAND gate. See the location where your file will be stored, it will be represented here C: under Xilinx folder, that is C drive under Xilinx folder. Your file name NAND gate will be saved. Just press next, press finish. So once we created the project name, then go under project, select new source. Here we have to select the Verilog module because we are writing Verilog program. So select the Verilog module. I selected Verilog module. Give the Verilog module name. This name you can give same project name or you can give the different name also. So I given same name as project name. Press next, press next, press finish. So once if you created the project name and as well as module name, so here general Verilog syntax will be generated in the text window. So now here you have to write the program of the NAND gate. So I already explained the logic of the program. Just I will copy the program and I will paste it in the program window. So here in the constraints A comma B comma Y. So after writing your program, just save it. Here you have the save button. Then select the implementation. After selecting implementation, select your file name NAND gate. Once if you selected file name, go under synthesize here. Under synthesize, check syntax. Double click on check syntax. It verifies the syntax of your program. You type the keyword names and also the variables that terminated with semicolon and all of these syntax it will checks. If everything is correct, it gives the right mark. Otherwise, it gives cross mark. And whatever errors will comes, that will be represented in this console part. By clicking on errors, you will get here. In my program there is no errors, so the right mark we got. And if you want to see the schematic of this program, so double click on this view RTL schematic. It gives the schematic representation of your program. So in your program you consider the inputs A, B and output Y. With respect to that, and in this schematic, whatever your program you wrote with respect to logic, that schematic will be generated for input and output. So here you select start with a schematic, then press OK. So here you can see the model name we given as NAND gate, and with respect to the input and output variable, the schematic will be generated. AB is the input and Y is the output. Just you double click on this, you will get internal structure. So our NAND gate, as I told, first it takes the product of inputs, that is AND operation. Then whatever will get the product, for that it will give the complement. So AND gate with NOT gate, so we will get the NAND operation. This is the schematic representation. Now we have to see the simulation of the program. So select here simulation, then select your file name NAND gate, go under iSim simulator, double click on behavioral check syntax, then double click on simulate behavioral model. So here it goes to the waveform window. So there you can give the input variable values and you can check the what is the output for with respect to the input combination. So this is the waveform window. Here you can observe the variables, input and output variables A, B and Y. So you can give the variable A value. So right click, go to force constant, give force to value. I'll give it as 0. Then cancel after time offset. So when you want to end the time level of your waveform, so I'll give 2 picosecond, apply and OK. Then another input value B, right click, force constant, I'll give this is also 0. Then I'll give time elapsed 2 picosecond, apply, OK. So once if you give the input values, just here run the option. So you'll get the output waveforms. Here you given A is 0, B is also 0, 0 into 0 is 0, the complement of 0 is 1, so your output is 1. You can observe here 0, 0 and 1, and with respect to values the waveform. So this is first combination. Next combination, select A value, force constant, give A is 0 and time elapsed 2, apply, OK. And B value, force constant, I'll give B is 1 and time elapsed 2, apply, OK. So then run it. See the second combination, for second combinations, so A is 0, B is 1, your output is 1. So because 0 1 is 0, that complement of 0 will be, see here the output 0, A is 0, B is 1, the product is 0, then complement of that will be 1. So that is NAND gate operation. This is the second combination. Then third combination, I will give A now 1, time elapsed 2 picosecond, apply, OK. Then B value, force constant, I will give 0 and it is 2 picosecond, apply, OK, and run. See, in the third combinations, A is 1, B is 0 and your output is 1, because 1 0 is 0 and complement will be 1. So 1 0 1. The last combination, A is 1, time elapsed 2, apply, OK. B value, force constant, B is 1, time elapsed 2 picosecond, apply, OK, and run. See here the last A is 1, B is 1, the product will be 1, but complement of that will be 0. So this is our NAND gate operation. I shown all the 4 combinations. I hope you understood what is the NAND gate and how we can get the output waveforms. And also I want to tell, this NAND gate is called as the universal gate. Why it is called as universal gate? We can obtain all the basic gates, that is NOT gate, AND gate, OR gate, XOR gate. We can form all the basic gates by using NAND gates. That is the reason this NAND gate is called as universal gate. In almost all in competitive examination, they will ask this NAND gate is called as basic gate or universal gate. If it is universal gate, why it is called as universal gates? Okay, I hope you understood the operation of the NAND gate, and also you analyze what is Verilog program and how we can write the Verilog program. If you like this, please subscribe and share it, and also inform to your friends. Please watch again and again. Thank you.